If my problem is 100 minus this, right? In fact, it's 100.00 minus this. Watch what I can do. Watch what I can do. I'm going to take this down by 1, make it 99.99, and then I'm going to take this down by 1, 64.24. If I have a subtraction and I change both of the numbers by the same amount, the result's the same answer. But instead of a bunch of frickin' zeros, I got a bunch of frickin' nines. Nines are the most beautiful number to have in a subtraction problem. You ain't never going to have to borrow for that shit. It's always going to be at least as big as the one below it. You guys semi with? And again, do you have to do it this way? No. If this makes no sense to you, never do it this way. I love it. But you're going to get the same answer either way. Well, do we? Let's see. So here I don't have to worry about anything. And if you do it that way, do you get the same answer? Yes, you do. Right? You like that? That's a cool little trick, and it's not difficult to really understand. The way I use it the most of the time is if I have to do 1 minus 0.3718, for example. Watch this trick. It's kind of related to this, making a bunch of nines, right? So watch. If you ever have to do 1 minus a decimal, what makes this 9? 6. What makes this 9? 9. 2. What makes this 9? 8. What makes this 10?
1. 2.
Make everything 9 except for the last guy. That's the shortcut to doing that, and it's related to that. All right, enough. So if you don't have to use any shortcuts that you don't want to. They're only there if they make sense. Okay, maybe. So you can always just do it the long ass way. It's always there. Okay. I'll let you guys, like, no reaction. I don't know if you love it, hate it. I don't know. You're like, that was stuff. Yes?
So, the 0.6282
Is what that is.
oh,
Yep.
okay, just to convert it to 1?
No, just what's 1 minus this?
Oh, it's.
If I make everything 9, 6 makes that 9, 2 makes that 9, and then make the last one 10. Do you see, real quick, if I added these, that looks like 9, 9, 9, but that's 10, so it would carry, and it would make it a full 1. That's why 9, 9, 9, 10 is a great shortcut and is related to that idea down there. Okay, I don't know. So this is like all the people that can do math real quick in their heads, they just know a bunch of shit like that. Right? Like, this guy. Okay. All right. So I want to move on. We got to get into a certain thing here. We got like 10 minutes. I want to do a certain little thing here at the end. Not a little thing either, but it's kind of a huge thing. So let me see how you guys feel about this. The bread and butter, I would say, of algebra is solving equations, right? So what I want to do, in real life, equations come from observations we make. We see relationships within things. We write equations that represent those relationships. So for example, if you got paid $10 an hour, right? Remember my first job, I got paid $3.25 an hour. But if you get paid $10 an hour, can you write an equation that tells me how much money you get paid for any amount of hours? So say the amount of hours you work is X, and you get paid $10 an hour. What do you do with those two? So if you worked for 7 hours, how much would you get from that? So we're ignoring taxes for the moment, which you wish you could do in general, but do it. So the general equation would just be, yes, or even better, 10x. So I'd say y equals 10x. That would be an equation that represents how much money you'd make if you worked X hours and you got paid $10 an hour. That is a remarkably basic equation. So if I want to write an equation that models the weather, do you think it will be as simple? How many variables affect the weather? A lot. And are they all affecting them linearly? No, right? So you see these models of weather, and especially like hurricanes, for example. I'm not going to talk about any presidents and Sharpies, but you see these models and they all kind of disagree with each other because they all kind of take the variables and use them in slightly different ways. So very often when we see a hurricane trajectory and it's got that cone that gets wider, it's because they're trying to average all of the models together. All right, I'm not doing all this to make you feel like we're going to suddenly do meteorology. We're not. In real life, equations come from observations we make so we can try to make predictions. That's one big place where equations come from. Right now, we're going to just create some freaking equations out of nowhere. Because we don't want to try to predict the freaking weather, especially not in San Diego. Let's say that x is, give me a number.
4.
4, kick ass. So let's start building an equation. What is 2x then? It's got to be 8. You guys with me? So what is 2x minus 7? Is everybody with me? Right? So all we do, if I give you an equation like this and I say solve this, you are trying to undo all the shit that some imaginary person did to x. You're trying to unbury the x. So you're trying to do all the opposite stuff. So you're trying to do everything we just did, you're trying to do it in reverse. So in reality, equations don't come from somebody doing this shit, but I can still look at them the same way. I want to try to get my x by itself and get all this other crap out the way. Right? So how would I solve this? I would first add 7. And then divide by 2. All right? And of course we know that's the right answer because we started with it before. So we're just trying to unbury the x from underneath all this crap that somebody did to it. Poor little x dude. All right, we're like the St. Bernard trying to get somebody out of an ambulance or something. I'm coming for your x. I don't know why I'm so worried about my x. Anyway, I won't get into that. So for example, let's start off nice. If I had 6x equals 24. Yeah, so what you're really asking yourself is, why is x not by itself? Stupid 6. What's the operation that the 6 is doing? Multiplying. So how do I kill it? Do the opposite, right? So if I divide both sides by 6, this is where I get people doing this neat shit though. What would you tell somebody who did that? Unless it's yourself, and then, I don't know how much you talk to yourself. But, right? Why is that wrong? Well, it's not just because it gives you the wrong answer. It's because subtraction does not cancel multiplication. That's not its job. What is 6x minus 6? 6x minus 6. You actually made the problem look worse. What the hell? So you have to stop yourself and say, what's the operation right now? Let me do the opposite. Because that's the only way things can cancel. So you want to divide both sides by 6, so I get x equals 4. And then how do you check that? You plug that value into the original. So 6 times x, but I'm saying x is 4. Is that equal to 24? Yes. Yay. And they all celebrated. This room is not really set up for anything. Sleep. Not screw it. All right, we're almost done. So what about this one? So x minus 11 equals negative 3. Yeah. I like it. Yes. Why is x not by itself? Stupid 11. What's the 11 doing? Subtracting. How do you kill it? Add it. And again, let me say this again. I'm going to say this a few times. If I'm doing something that you're like, holy shit, why is he going so slow right now? Deal with it. Right? Just enjoy the moment. Because your hard part's coming. But this is somebody's hard part right now. So that's who I'm mostly talking to. So if you add 11 to both sides, what is negative 3 plus 11? Another way to think about that is, negative 3 is like 3 foot down. If you climb up 11 foot, where are you? If you're 3 foot down, how much you have to come up to be ground level? 3. And then how much further am I still going to go up? 8. Right? I don't know, that's maybe not the best way to think of it, but I always like to think negative is down, positive is up. Adding is going up, subtracting is going down. Right? So some people have trouble with, like, what's negative 7 minus 12? Nope. Negative 19. I'm down 7, and I go down another 12. So I'm down 19. What's negative 7 times negative 12? Oh, shit. Yes, the answer will be positive. Why? Because multiplying two negatives cancels each other out, right? And 7 times 12 is? Right, 7 times 10 is 70. 7 times 2 is 14. 70 and 14 is 84. Kick ass. Kicking the ass. All right, one last problem, then we'll head out. What you got, Jeff? I don't know. Yeah, sure. I like it. Good. So we're going to slowly start to make our equations uglier. Why? Not just because we're evil, but because equations that govern real life are almost guaranteed to not be pretty. And that's the whole point of this, is to help us get ready for dealing with real life. And I know that you can go through life without doing any algebra ever. I know that. But if you know some algebra, are there doors that open that can make your life better? Yeah. Right? I had some idiot write on my YouTube once, I make 5,000 a year, I'll do any else. That's nice for you. Imagine how much you could be making if you actually knew some math. It'd be amazing. Right? But not everybody can luck into whatever the hell you did, so step back. All right. So first thing you do, yeah? Why can't I, like, add 1 to both sides?
Because you have to do the...
Why? Because the negative 1 is stuck inside right now. It's not free to move around. And then what do I do next?
Add 4.
Good. Because you're always trying to get the thing with x in it by itself. You almost always divide last. So, yes?
The x 4, we got 4, x, like x is 4.
Sorry. Yeah, 4 times x is 4x. And 4 times 1 is 4? Is that?
No, I mean, the 1, you got, how you got 4? 1.
Here?
Yeah, how you got 4? Yeah.
Oh, all right. Here's a good point. Okay. Here. We won't finish this. I want to show you this. So why does distribution work? This is the last thing we'll do, I promise. Does anybody ever know why distribution works? I'm going to do this a lot. I don't know if you picked up on this.
Wasn't the parentheses just multiplication? So you're going to 4 times x.
Sure, but why should it distribute to both the way it does?
Because you can't combine x.
What does order operations say to do? What's the very first thing I'm supposed to do?
Parentheses.
Yeah!
Yeah.
So somebody should be upset, like, holy shit, I should have to stop because I can't do x minus 1. Now watch. Remember what 4 somethings means? It means those things added 4 times, right? So what is 4 of these? X minus 1 plus x minus 1 plus x minus 1. Right? Is that cool? Plus x minus 1. Isn't that what 4 of these means? And then I can just add my like terms. So I'm not breaking order operations. I'm rewriting the problem so I can do it better. So what I get, x plus x plus x plus x is 4x. Negative 1 minus 1 minus 1 minus 1 is negative 4. So then the shortcut, don't do all this shit. The shortcut is just, I'm going to get 4 of these, and I'm going to get 4 of those. That's why distribution works. Okay. Yeah, I'll keep this for next time. If you want a copy of the chapter, the section 2-1 homework, you need a copy of that. It's right there. Otherwise, you're free to move about the country. No. Okay. I do. Do you have a minute? Come back with me to the office. Officially. Aren't you all? That's for section 2-1, right? And you got the homework assignments, you can see exactly which ones to do. Right? You don't have to do all of those. Yeah. Sweet, thank you.
Do we need to do this homework?